Good afternoon, judges and audience. We are Team Arivda from BCA Academy. It is a great honor for us to join this presentation here. And I will introduce myself. My name is Wen Ke, as a team leader, and also take part in MVP design. She is Momo, responsible for architecture. He is Simon, construction model. And the cost estimation responsible person for Wan Jun. Now my teammate will start the presentation right now.
Firstly, I would like to present about site analysis of the given size. In this site analysis, you can see the main circulation route, which is red color. Though there are some vehicular circulation, most of the people use MRT than buses. The following are the surrounding buildings of this site. They are Changi Business Park, Changi Point, ITE, Design and Technology University. This study about site analysis of the given sites. For the strength, the site is near to the MRT and bus stop. But for the weakness, the main entrance of the building is facing to the busway. But most of the people use MRT than bus. MRT to all of the 6 halls have only one long route. So the visitors who are visiting to the last hall need to wait along way back to the MRT. For opportunity, the site is near to the airport, so in the future there will be some development such as commercial usage or something like that. Based on site analysis, this is our design concept. In this design concept, we change the main entrance of the building. The main entrance of the building is on the Expo Drive, which has heavy flow. The yellow color represents the 6 exhibition hall. They are the same shade to get visibility score. The blue color represents the shopping mall, which make our design to have sustainable concurrent usage. The red color represents the foyer and office, which have the visitor about the information of the building. At the central spine, the green area is the internet courtyard of the building. This slide shows how we improve our mezzanine model. We produce a few mezzanine model and consult with the final mezzanine model, which is on the right side. The back side of the building has 2 levels. Each level has 3 halls, which can replicate for visibility. We designed it 2 levels, not to waste time by transferring one hall to another, and to reduce the travel distance to the MRT. And the internet courtyard and the main circulation also have the MRT user in way go back to MRT for aesthetically pleasing. This is the render of our model with landscaping. In this landscaping, we use lots of trees because to improve the building aesthetically and also to reduce heat. The building use U-value glass for the front facades. At the back facades, we have lots of green wall, and also 60% of the whole site is green area. We plant lots of trees because there are some vehicular circulation around this site, such as MRT route, which make lots of noise. By planting lots of trees, we can reduce this sound level. And also for the construction part, one of my members will carry on the next slide.
Yes, this is our structural model for our using our Expo, and we use reverse structure to construct these models. And you can see that the most are high mass and reinforced concrete structures. And for the superstructure, we apply 50-meter long 4x cap to support the heavy weight loading, and then followed by 3 slabs and a column. And the roof is we use truss. And the 4 column mainly are 1 meter dimension for the exhibition and most of the building. And the beam and slab is in various size in each building and level and story. And these buildings are we are designed to use pre-truss and semi-pre-truss beam, and most are standard size, so this will be more visible and productive and can be built faster and economical for construction. And for the finishes, and we consider of lightweight concrete and some recycled materials, that this can provide more and better heat isolation and sound isolation and sustainability, and also is very good for environment as for the future. And this the next part is reinforcement detail for our construction. And here you will see the slab section being foundation detail. First of all, for reinforcement delay, we line that we taught in our school, and use some single standard core brackets to calculate the number of beams for the component, and this the beams and its social models. And I will pass to this one.
Okay, here's a typical layout of four MEP system. Includes lighting, plumbing, fire protection, and AC room. What we focus for all the system is whether the minimum Singapore standard is satisfied, such as the minimum lighting level, airflow rate, and room temperature. This slide shows the analysis of the energy consumptions. From the top left-hand side shows the ACMV shows the energy consumption of the composition of energy consumptions for the main features. And the top to the left right-hand side shows the monthly cooling out. From here we can see the most energy is using by ACMV system. So we have to put more attention on here. And the graph shows the wind growth direction, so in whole year. That is for us to find out the most place to locate the cooling tower, to reduce the effect on buildings and same time to increase the cooling tower efficiency. Also, we focus the carbon dioxide emissions, which exceeds 3,000 tons per year. And the last, after the improvement, and calculate the energy consumption referred to commercial conditions. Finally, theoretically, we achieved about 35% energy saving. And this slide shows a brief introduction of our simulation simulation layout. Is by using beam rebate and equal-tipped, includes wind tunnel, solar and solar heat simulations. From those simulations, we can do our improvements under the practical conditions. Now, my teammate will take part in the clash detections.
Now I'm going to talk about the clash detection, the analysis of GFA as well as the cost estimation. For the first part, I'm going to talk about the clash detection. For this part, we use Navis work to do it, and we import the Revit structure, the architecture, as well as the MEP model into the Navis work, and use the clash detective tool to check whether there was any errors and clash. And for this picture is to show you how these three parts coordinated with each other. And for the top picture is to show you one of the interruption of our design. In this picture, you can see the area which is highlighted in red color. It shows us the interruption between the HVAC system and the beam. Therefore, we inform the structure team and MEP team to do some correction. The last picture below is to show you the correct one after our improvement. The next part, I'm going to talk about the GFA, car park, as well as the cost estimation. For GFA, the total GFA of the building is about 186,000 square meters, and it includes the commercial shopping area and the convention exhibition center. For the first part, commercial shopping area is about 68,000 square meters, and the convention exhibition center is about 118,000 square meters. The plot ratio is equal to 0.788, which is higher than the recommendation of this competition, which require us to design 40% of the GFA is about commercial area and 60% is about the convention area. The schedule here is to show you we have designed 1,357 lots for the car park. 12 handicap accesses is included in this part. And the last part, I'm going to talk about the cost estimation. For this part, we use cost X to do this part, and we also imported the 3 model into the software cost X and used the big data as our reference to calculate the cost. After our calculation, it cost us approximately about 500 million Singapore dollars to finish this new project. Then I pass to my team member to continue.
Okay, here comes the last part of our presentation. After applying for BCA Green Mark criteria, a total 96 points scored. Meanwhile, the new building wins the Platinum Award, except the most part is energy efficiency, covered 35 points gain, and we put plenty of effort on sustainable operation and management, which gained 25 points. Among all the parts of energy efficiency covered most of the points gained. This provides our new design is conductible under Green Mark management. By using the simulation software after improvement work, green fixtures, renewable energy, and low-E painting covered the exposed area, 35% of energy saving achieved, with low ETT rate 40 watts per meter square. The second is water efficiency, supported by rainwater, storm, and redistribution for the irrigations, and after treatment for cooling tower usage. The third one is environment protection. We provide the green wall construct and the back of the building. Also, we plant the numbers of trees to reduce the soil erosion and grow habitat. This part ensures we gain the score under environment protection. We also adopt some improvements on indoor environment quality, such as natural light and natural ventilation for the top level, and we plant trees within the building to reduce the noise level, also enhance the appearance of building. The last one is other green features such as transport. It shows that our building is located near the MRT station, and we set Green Mark Manager. Also, we use self-clean facade system. Okay, this is all of our presentation. Right now, my teammate will start our conclusions.
Yes. In contrast, our new Singapore Expo will provide more consideration in terms of productivity, metaverse, and stability, and it also conduct higher energy and water efficiency and green environment, and considering for long term. As the shopping mall and most of our exhibition halls can be available and useful for all activity and events, and it more good points and good performance than the current one. And so this will be a leading business hub with high technology firms, facility, and mother companies in lots of industries, and active urban ecosystem and green environment system. And additionally, and more important, we become good friends, seeing our competition and learn to be cooperate and coexist and work together for a common goal. We all know that talents win games, but championship, teamwork wins championship. And we all feel that this competition is like a real project for us, and we did marvelous jobs. And thank you for organizing these competitions. Thank you for listening. It's the end of the competition. Thank you.
In designing on the planning on the sequencing of the development.
Actually, based on the site analysis, we know that most of the people use the MRT, and then they have the less busway. So we think of our building orientation into the into the easiest way. We have something like entrance and then the system over there, and then for the MRT user, they can come from the yellow line. They can easily come to the foyer area and then go to all the hall and the shopping area.
What about the sun? Whether there's any strategy to avoid facing the west? Because in terms of environmental performance, you want to avoid the west.
We made a lot of green wall at the back side of the building.
Where's the north one? I mean, you put a plan, where's the north? Yes, I have a plan, right? Where's the north? Down. So the west is this side there. West is this side there. North is over now, right? Okay, good presentation. So actually, I just want to check because one of the requirements is for this competition is actually talk a bit more on how you actually collaborate with each other. Say for the architect, how you collaborate with the M&E, so on and so forth. So I was just wondering, I know you started with the concept model, so messing everything. So from there, how was this actually passed on to the structural side? Do you do it together? Because you have 48 hours, right? So how do you actually do it? Do you like finish the concept model, then this person take over, or you do it together? How do you do it?
For this part, before the competition, we designed 4 organizations. One file is for architecture, structure, and one file is for architecture, one file is structure, and MEP part. Then during the competition, when we finish one part, then we put in the form. Then the other team, the other group can link. Yeah, we link together.
Use the link between the archi model and structural model, so that if the archi part is a bit changed, structure and control the changing, so it's adaptable and can save time.
So this means it's more or less you finish the archi model, almost finished, then you.
Yeah, first is we finish 70% like that, and then structure can do.
So the other thing is just now, the lady, she was saying that you count all the kappa numbers, right? So how do you do it? Do you use text to actually count the numbers, or you actually count it physically? Is there evidence of it? I was wondering how do you use the bin tool to actually do that? You just count it, or what?
We just put the schedule, right? And then the review will count for us.
Count the kappa numbers, right?
Repeat data.
Okay. That's good.
My question is quite similar to Mr. Arivda. Basically, I think I would like to have a better understanding of the innovative or the use of the tools, the BIM tools, and to see how you integrate all these different tools. In total, how many software you use and how you basically integrate them together for giving a better understanding to it.
We use research for Archi and MEP, and some 3D Max and
3D Max and Ecotech. The first day we use in Revit, the version is 2012. But I make a mistake. I opened this version in 2013. So we have changed all the joins into 2013. They spent a lot of time. So after the joins, we just drop the files into the Ecotech or 3D Max to do the rendering or the simulation exercise.
Same thing on the collaboration, but from the start, do you all really think through the cost? Because I see that the cost is presented at last. After you finish everything, then you calculate the cost. Is cost designed as part of the collaboration from the beginning?
From the start, we do not think about the cost. We just all the group together, we just think about
Because we don't have any experience into the real project, so we just follow by our concept or what we are thinking about it.
I think in the interest of time, we better move on. I think this is one of the challenges most of the teams will face because they are quite new and probably have little experience in costume. So, yeah. You thank the team.